Hello students, welcome to memoneet. This is Ravikant, your physics teacher, and today we are going to discuss is your BPT 21 question paper. And the very first question says that an iron rod of length 2 meter and cross sectional area 50 millimeter stretched by 0.5 millimeter when a mass of 250 kg is hung from it. Its lower end, Young's modulus of the iron rod is. See, the Young's modulus formula for Young's modulus is Y is equals to stress upon strain. So stress is force upon area, and your strain is change in length, that is small l upon capital L. So this will turn out to be your F into original length upon change in length into area of cross section, right? And here area of cross section, for that area of cross section uh, and cross section area is given as 50 millimeters square. It should be millimeters square, right? So all these things are given. L is being given to you, A is being given to you, small l being given to you, F is given in the form of mass. You multiply with G, will get F, right? Putting these value in the formula, as you can see the calculations run over here, we finally get our answer as Y is equals to 19.6 into 10 to the power of 10 Newton per meter square, which is the option 1 of your question number 1. So the correct answer for question number 1 is option 1, and the formula used here is Y is equals to stress upon strain, that is Young's modulus is equals to stress upon strain, where stress is force upon area and strain is change in length upon original length, right? Now let's come to question number 2. Question number 2 says the force F is applied on a square area of side L if the percentage error in the measurement of length is 2% and that of force is 4%. What is the maximum percentage error in the pressure? The pressure is given as force or thrust upon area. So percentage error in pressure will be equals to percentage error in force plus percentage error in area, right? So, and percentage error in area will be equals to, and this percentage error in area will be equals to 2 times the percentage error in length, right? So, percentage error in length is 2% and percentage error in force is 4%. So, it will be 2% into 2, that is for force it will be 4 plus 2 times of 2. So, altogether it comes as 8%. So the correct answer for question number 2 is 8%, which is option 4, right? How it has been done, you can see because pressure is equals to force upon area and area is equals to L square. Therefore, relative error in pressure will be equals to relative error in force plus 2 times the relative error in length, right? So it has been given as 4 and this will be given as 2. Putting it, we get answer as 8%, right? Now then comes question number 3. Question number 3 says that an ideal gas is taken through a cyclic A to B, B to C, and then C to A as shown in the figure. We are going through a cyclic process as shown in the figure. If the net heat supplied to the gas in the cycle is 3 joule, the work done by the gas in the process C to A is in the process C to A. See, because this is a cyclic process, there will be no change in the potential energy, right? Means delta U will be equals to 0 here, right? And we know that delta Q is equals to delta U plus delta W, right? And because delta U is 0 here, we can say that delta Q is equals to delta W. Means whatever heat being supplied, that is been done as a work done. So what they are saying is an ideal gas is taken through the cycle that is from A to B, then B to C, and then C to A as shown in the figure. If the net heat supplied to the gas cycle is 3 joule, so whatever is the heat supplied is 3 joule is the amount of amount of the heat supplied, then 3 joule will be the amount of work done because it's a cyclic process, right? Now the work done by the gas in the process C to A, in the process C to A, while going from C to A, what is the amount of work done, right? So amount of work done in going from C to A will be given is calculated as C. Delta Q is equals to delta work done in moving from A to B plus work done moving from B to A plus B to C, then work done in moving from C to A. So now if you look into the graph, what we can see is that while moving from A to B, the volume is changing. So there is some work done. So A to B, there is some work done. Then while moving from B to C, there is a change in the pressure, but there is no change in the volume. Because there is no change in the volume, there will be no work done here. So we don't have any work done in moving from B to C. Then coming to C to A, there is a change in volume. That is, we change from 2 meter square to meter cube to 1 meter cube. See, at C it is 2 meter cube and at A it is 1 meter cube. So there, because there is a change in the volume, there will be an amount of work done. Now, if we talk about volume here in the process from A to B, there is an expansion. So change in the volume will be positive. Whereas from C to A, there is a decrease in the volume. That is, there will be a compression. So the work done will be negative, right? So we can say that that delta Q will be equals to your W work done from moving from A to B to work done from C to A. Now, in the question they are asking you to calculate the work done in from C to A. So, rearranging the question will give you delta Q minus W A to B and W B to C. Putting the value C, Q we have 3 joules and work done in moving from A to B. Work done in moving from A to B. A to B. P is 10 and change in volume is 1, right? And work done is given by W is equals to P dV, or pressure into change in volume will give you the work done. Pressure is 10 and change in volume is of 1 unit. So the work done will be of 10 joules. So we have taken it as 10 joule over here. And work done from B to C is 0. So we have taken it 0. So on subtracting it, we get our work done as minus 7 joules. So the correct answer for this question is option 1, that is minus 7 joule, right? So minus 7 joule. Basic thing is we should know that work done is equals to P dV here, and in the cyclic process delta U is equals to 0, right? If we know these two things, we can easily solve this question. Then coming to question number 4, the magnetic flux linked with a coil phi is equals to T cube plus 2T plus 1 Webers, where T is in seconds. The magnitude of the induced EMF in the coil at T is equals to 3 seconds. So induced EMF is given as E is equals to minus d phi by dt, right? So differentiating phi with respect to T, will get 3T square plus 2, right? This is what we get, 3T square plus 2. Now at T is equals to 3 seconds, T is equals to 3 seconds, we put 3 here, we'll get 27 plus 2, which is equals to 29 volts, right? So we get 29 volts as our answer. So question number 4 has the correct answer as 29 volts, that is option 3, right? Right. Now coming to question number 5. Question number 5 says that a light string passing over a smooth pulley connects two blocks of mass m1 and m2 and shown in the figure. If the magnitude of the acceleration of the entire block is g by 5, the ratio of the masses m1 to m2 is. So this is okay. So for such an arrangement, you can directly use the formula. If you remember, that is expression is given as m1 minus m2 into g upon m1 plus m2, and this expression is given as g by 5. Simply put the value a as g by 5 and then start calculating it for your m1 and m2. You will get m1 upon m2 is equals to 3 is to 2. Now from where this formula, the main formula, this formula comes as C. If suppose this is this is m1 and this is m2, right? So we can say this system is accelerating in this direction. This is the acceleration. So we're drawing the free body diagram for, let's say, m2. This is for m2. For m2, here we have tension and here we have m2 g its weight, and still it is accelerating in this direction. So we can write that T minus m2 g is equals to m2 into a, right? And if we talk, let me draw it here. If we talk about m1. For m1, here we have tension and here we have m1g, and still it is moving in a downward direction A. So we get our equation as m1g minus T is equals to m1 into A. Right. So from here we can say that T is equals to m1g minus m1a, and from here we can say that T is equals to m2a minus m2g. Sorry, m2a minus m2g. Right. And because this T and this T are same, we can equate them, and equating them we will get, let me write it here, we'll get m1g minus m1a is equals to m2a minus m2g, right? Now rearranging this will give you m1g minus m2, sorry, plus m2g is equals to your m2a plus m2 m1a. Something went wrong. Yeah, it's okay. Okay. So from here, if we write, we'll get m1 plus m2. Wait a minute. M T is equals to m2 minus g. Alright, so here it is the mistake. When the screen went up, so the mistake is here it will be plus, right? Because it is plus. So m1g minus m1a is equals to m2a plus m2g. So this will become m1g minus m2g is equals to m2a plus m1a. So finally we'll get this formula, that is m1 minus m2 into g upon m1 plus m2 is equals to a. Now from here, a, as in the question, a is given as g by 5, we put it as j by 5, and then we calculate, we get the ratio of m1 upon m2 as 3 upon 2. So the correct answer for question number 5 is option, question number 5 is option 2, that is 3 is to 2, right? Now let's come to question number 6. Question number 6 says a gas mixture consists of 4 moles of oxygen and 6 moles of helium. 4 moles of oxygen and 6 moles of helium. Oxygen is diatomic gas, helium is a monoatomic gas at temperature T. Assuming the gas to be ideal and the oxygen bond to be rigid, the total internal energy of the mixture is. Now, if we look into the solution, what we can see is that oxygen is a diatomic gas, so the degree of freedom will be 5. Helium is a monoatomic gas, so degree of freedom is equals to 3. The internal energy of the gas is given by the formula U is equals to F1N1 RT upon 2 and F2N2 RT upon 2. Putting the values of F1 and F2 and N1 and N2, right? And solving it, we get the internal energy as 19 RT, right? 19 RT. So the correct answer for question number 6 is option 3, that is 19 RT. Now coming to question number 7. Question number 7 says that find integral of 1 upon root x from 0 to 4. So integrating this, we will use the formula integral of x raised to the power of n dx is equals to x raised, sorry, n x raised to the power of n plus 1 upon n plus 1. So here the power on x is minus 1 by 2. Power on x is minus 1 by 2. So minus 1 by 2 plus 1 will give you 1 by 2, and in the denominator also you will write 1 by 2. So the integration will be equals to x raised to the power of minus 1 by 2 plus 1 upon minus 1 by 2 plus 1. So this will give you x raised to the power of 1 by 2 upon 1 by 2. So this will be equals to 2 times of x raised to the power of 1 by 2, which is equals to 2 times of root x. 2 times of root x. Now we have to put the limit. limits from 0 to 4. So upper limit minus lower limit, upper limit is 4. So root of 4 is 2 and minus lower limit, so it is 0. So 2 into 2 minus 0 will give you 4. So the correct answer for question number 7 is option 3, that is 4 is the correct answer. Option 3 is the correct answer and option 3 is 4. Now question number 8, if a body is moving uniformly in a circle with speed v, then the magnitude of change its velocity when it is turned by an angle theta is 2a cos theta by 2, right? 2a sin theta by 2, right? See, we have studied in vector that if there are two vectors which are of equal magnitude, let's say A, and they make an angle theta, then their sum is equals to 2a, magnitude of their sum will be equals to 2a cos theta by 2. In the same way, if we are not finding the sum, if we are finding the difference of these two vectors, then the magnitude of difference of these two vectors will be equals to 2a sine theta by 2. 2a sine theta by 2. So according to this, the correct answer for question number 8 is option 4. But still, let's see the elaborated solution of this. Right. Now see, if the final velocity v is equals to v sine, see, initial velocity is u is equals to v j, means it's along y axis. Now final velocity would be v and it would be in a xy plane. Xy plane, that is in the negative x axis, and it's a positive y axis. Now change in the velocity will be final velocity minus initial velocity. So v sine theta I cap plus v cos theta minus v j cap, right? And then solving it for and calculating the magnitude, we get 2v sine theta by 2, right? So instead of doing all this whole calculation, it's very easy for you to remember that if there are two vectors and both the vectors are having equal magnitude, they are at different direction and the angle between their direction is theta, then the resultant vector means the sum of the two vectors will be exactly between the two vectors and its magnitude will be equals to 2a cos theta by 2. And if we are willing to calculate the difference between the two vectors, then the answer will be equals to 2a sin theta by 2, right? Now next come to question number 9. Question number 9 says the voltage between the the voltage between the plates of parallel plate condenser of capacity 1 microfarad is changing at a rate of 5 volt per second. The displacement current is. So displacement current is given by C dV by dt. I d displacement current is given by C dV by dt. Now, as per the question, you can see the capacitance C is given as 10 to the power of minus 6 farad, that is 1 microfarad, and the rate of change of voltage dV by dt is given as 5 volt per second. So putting those values in the question and the formula, we get displacement current as 5 microamperes. So 5 microamperes is the correct answer for question number 9, which is our option number 4, that is 5 microamperes. Now coming to question number 10. Question number 10 says the moment of inertia of a disk of a radius 0.3 meter about its geometric axis is 2 kg meter square. If a string is tied to its circumference and a force of 15 Newton is applied, the value of angular acceleration with respect to the axis will be. Now given is the radius of the disk is r is equals to 0.3 meters and the force applied is of 50 Newton. So moment of inertia is given as 2 kg meter square. Now we know torque is equals to F into R, so tau is equals to F is 0.3 Newton and R radius is given as, so how much? F is 15 Newton and R is 0.3. So putting these value, we get torque is equals to 44.5 Newton meter, right? Now tau is equals to I alpha. Tau is equals to I into alpha. tau is torque, I is the moment of inertia, and alpha is the angular acceleration. So from here we can calculate alpha. So alpha will be equals to tau upon I, where tau is 4.5 and I is 2. Calculating this, we get alpha, that is angular acceleration, as 2.25 radian per second square. So the correct answer for question number 10 is 2.25 radian per second square, which is our option 3. So question number 10, option 3 is the correct answer. Question number 10, option 3 is the correct answer. Coming to question number 11, in a AC circuit, instantaneous current is given by I is equals to I naught sine omega t, and omega is given as pi by 6, right? The time from starting when current in the circuit becomes equal to its RMS value for the first time is RMS value. That is, they are saying I is equals to I naught upon root 2. So I naught upon root 2 is equals to I naught into sine pi by 6 into t. So I naught and I naught cancels out. What we are having is 1 by root 2 is equals to sine pi by 6 into t, right? This is what we are having. So from here we can say sine pi by 4. Pi by 4 is equals to sine pi by 6 into t. So we can say that pi by 4 is equals to, let me write it here, pi by 4 is equals to pi by 6 into t. So pi and pi cancels out. We get t is equals to 3 by 2 seconds. 3 by 2 seconds is nothing but 1.5 seconds. So the correct answer for question number 11 is 1.5 seconds. That is the first option, that is 1.5 seconds. Coming to question number 12, the distance x moved by a body of mass 0.5 kg under the acceleration of a force varies with time t as this. What is the work done by the force in the first 2 seconds, right? So see, mass is given as 0.5 kg and displacement is given in the terms of t like this. So if we differentiate it, we will get velocity. So v is equals to dx by dt, and differentiating this 2t square plus 4t plus 5, we get 6t plus 4. This is what is the velocity of the object under the influence of the force. Now by work energy theorem, the total work done will be equal to the change in kinetic energy. So at 2 seconds, we put 2 here, we get 6 to the 12, 12 plus 4 is 16. So we get speed at 16. After 2 seconds, the speed will be 16 meter per second, right? And at t is equals to 0, that is initial velocity, t is equals to 0, we get initial velocity as 4 meter per second. So from these two different velocities, we can calculate two different kinetic energy, but that is, one is the initial kinetic energy, another is the final kinetic energy, and subtracting them, we can get the change in kinetic energy. We get the change in kinetic energy as 60 joules, and because whatever is the change in energy, that will be equal to the amount of work done according to the work energy theorem. Therefore, since the change in kinetic energy is 60 joules, hence the work done will be of 60 joules, and that is our option number 4. Option 4, that is question number 12 has correct answer as option 4. Right? Now, okay, now let's see the next question, and the next question says that a hollow insulated conducting sphere is given a positive charge of 10 microcoulomb. Insulated conducting sphere. So all the charge will be on the surface. Because it is a conducting sphere, so all the charge will be on the surface, and the charges of 10 microcoulomb. Okay, now what will be the electric field at the center of the sphere if the radius is 2 meter? The electric field inside will be equals to 0. So the correct answer for question number 13 is option 3, that is 0. Why it is 0? Because by Gauss theorem, phi is equals to q upon epsilon naught, where Q is equals to the amount of charge enclosed within the Gaussian surface. So if it is a conducting sphere, all the charge will be on the surface, right? Not inside. At any point inside, if we draw a Gaussian surface, there will be no charge enclosed inside it. Now, because there is no charge enclosed inside it, the flux linked there will be equals to 0. And because flux is equals to 0, E will also be 0, because E is equals to phi into A, right? So your electric field will be equals to 0 here inside the conducting sphere. Now see, as you can see in the diagram, uh, if this is the sphere, all the charge get accumulated on the surface, right? Now integral E dot ds will give you the, sorry, yes, मैंने E is equals to phi into A कर दिया ना, phi is equals to phi is equals to E dot A. Now because phi is equals to 0, A cannot be 0 here, so E will be equals to 0, right? Simply Gauss theorem, use the Gauss theorem, the amount of charge enclosed within the Gaussian surface. So because all the charge is on the surface of the conducting sphere, there is no charge inside the sphere, so as therefore the what electric field will also be 0 there. So the correct answer for question number 13 is option 3, that is 0. Coming to question number 14. Question number 14 says that the volume of a block of metal changes by 12% when it is heated through 20 degrees centigrade. The coefficient of linear expansion of the metal is, okay. So the change in volume of the material can be expressed as delta V upon V is equals to gamma into delta theta, right? Change in the volume with respect to the original volume is gamma into delta theta. So gamma is equals to 3 times of alpha, right? What are gamma and alpha? Gamma is the cubic coefficient of cubic thermal expansion, that is volumetric thermal expansion, and alpha is the coefficient of linear thermal expansion, right? So they have given in the question, they have given that the volume of the block changes by 12%, right? 12%, and they are asking you the linear expansion, coefficient of linear expansion, means they are asking you alpha, and they have given you change in the volume, means from the change in the volume you can calculate gamma, and if you know the relation between gamma and alpha, you can then only you can calculate alpha, right? So delta V upon V is 12%, that is alpha V upon V is equals to your gamma into delta t, and gamma is equal to 3 times of alpha, so we have written 3 times of alpha over here, and then solving, putting the value, delta t is 20, right? Because they say the temperature is, it is raised through 20 degrees centigrade, so delta t will be equal, delta theta will be equal to 20, 3 times of alpha is equal to delta v upon v, so delta v upon v is 12%. Putting the value, solving, we get alpha is equal to 2 into 10 to the power of minus 5 per degree centigrade. So the correct answer for question number 14 is 2 into 10 to the power of minus 5, which is option 1, right? So coming to question number 15. Question number 15 says that an LCR circuit, series circuit with a resistance of 100 ohm is connected to a source of 200 volt RMS, right? And a regular angular frequency of 300 radian per second. When only the capacitor is removed, the current lags behind the voltage by 60 degree, okay. And when only the inductor is removed, the current leads the voltage by 60 degrees. Then the average power dissipated is. Now see, tan phi. From where we are getting this tan phi? We are getting this tan phi from the impedance triangle, which says that if this is an impedance, if this is a right angle triangle, then this will be your impedance, this will be VL minus VC, basically the difference between VL and VC, and this would be equals to your R. Now, and this will be the angle phi, right? So phi, tan phi is perpendicular upon base. So here see, tan phi, when the capacitor is removed, only inductor is left. So XL upon R, XL upon R. At that, for that case, phi is equals to 60 degree. Tan phi is equals to XL upon R. It means that XL is equals to root 3 times of R, and we have R as 100. So from there we can say it will hold some value. On the other hand, when the inductor is removed, then also tan phi is equals to XC upon R. So tan phi is tan 60 is equals to XC upon R. So XC is equals to root 3 upon R. Now XL and XC are equal. If we can see that XL is equals to root 3 upon R and XC is also root 3 upon R, right? So we can say that if XL and XC are equal, then this circuit is in resonance. And if this is the case, they are in resonance, the impedance of the circuit becomes equal to the resistance of the circuit, right? So what they are saying is that when only this is the average power dissipation. So average power dissipation is IRMS. Average power will be equals to VRMS into IRMS into cos phi, right? Now we have VRMS as 200, but we need to calculate IRMS. So IRMS is equals to IRMS is given as your VRMS upon impedance. On impedance over here is equals to resistance. So VRMS is 200 and R is equals to 100. So we get IRMS as 2 amperes, right? Now P average is equals to VRMS into IRMS into cos phi. So because it is behaving like a pure resistive circuit, so cos phi will be equals to 1. That is phi will be equals to 0. So cos phi will be equals to 1. Now putting the values, VRMS is equals to 200 and IRMS is equals to 2 and cos phi is equals to 1 or phi is equals to 0. We finally get the power average as 400 watt. So the correct answer for question number 15 is option 4, that is 400 watts. Next, come to question number 16. The charge flowing through a resistor R varies with time as Q is equals to A minus Bt. The total heat produced in R in T seconds is, see, if it is Q is charge, so dQ by dt is current, right? So if we differentiate it with respect to time, we will get minus d and this would be equals to current. And they are asking about the heat produced. So heat produced is given by I square RT. I square RT. What is I equals to minus b, so I square will be equals to b square into R into T. So this is the amount of heat produced in 8 seconds. So b square RT is your option 3. So the correct answer for question number 16 is option 3, that is b square RT, right? Now coming to question number 17, a ball is dropped from a high rise platform at t is equals to 0 seconds starting from the rest. After 6 seconds, another ball is thrown downwards from the same platform with a speed of v. Two balls meet at 18 seconds. What is the value of v? So a ball is dropped from a height at t is equals to 0 and after seconds another ball is thrown downwards. Okay. Now when it is being thrown downwards, it is being thrown with a speed of v and we need to calculate this speed, right? We need to calculate this speed and then we have the formula with us. Now options with us. Now we will use the equation as s is equals to ut plus half a t square. For the first ball, initial velocity is equals to 0 and then putting the value that half a is taken as 10 and 18 is the time in which we have to calculate the displacement. So it comes as 1620 meters. 1620 meters. Now why we are taking time as t 18 as t as 18, because at t is equals to 18 the balls are meeting each other, right? Now for the second ball, we have s is equals to ut plus half a t square. So u here will be equals to v. Now solving this, because both the balls are meeting each other, so the displacement for the second ball will also be equals to 1620. So 1620 is equals to Your this is ut plus half at square. Putting the values and we get the value of v as 75 meter per second. So the correct answer for question number 17 is your option 2, right? So what we have done here is that for first ball we have calculated the displacement which comes as 1620, and because both the balls are meeting at the same point, so the displacement for the first ball will be equal to the displacement of the second ball in 18 seconds, because both are meeting at 18 seconds. So the displacement of the first ball will be equal to the displacement of second ball. First ball has initial velocity as 0, second ball has its initial velocity as v. Now we can equate both and then solve out. We can get the value of v, and the value of v comes at 75 meter per second, right? So now let's come to question number 18. Now question number 18 says that the average EMF induced in a coil with the current change from this 2 ampere to 4 ampere. So we have E as 8 volts and change in current is from 2 amperes to 4 ampere, that is 2 amperes, and the time is delta t is equals to your 0.05 seconds, right? 0.05 seconds. They are asking you the self inductance. So self inductance is given as your, we know that the formula is E is equals to L di by dt. So from here we can say that L is equals to E into dt by dl. So here self inductance L will be equals to EMF is given as how much? 8 volts into delta T is of 0.05 upon delta I. Change in current is of 2 amperes, right? 2 amperes. So calculating this, we get L is equals to 0.2 Henry, right? So the correct answer for question number 18 is option 2, that is 0.2 Henry. Again, direct formula based the question, right? Next, coming to question number 19. Question number 19 says that the amount of energy required to increase the radius of a soap bubble from 2 centimeters to 4 centimeters is nearly, surface tension is given to you, right? So surface tension of the soap is given to you, radius has been given to you. Now we need to increase the size of the radius, that is from R1 to R2. R2 is 4 centimeters. Now the surface energy of the bubble is given by E into T. E is equals to T into A, where E is the surface energy, T is the surface tension, and A is the area, surface area. Now surface area of the bubble, because it's a sphere, so its surface area is equals to 2, sorry, surface area will be equals to 4 pi r square. Now because it's an air bubble, so therefore it will be having two surfaces, one is the outer surface, other is the inner surface. So we will multiply the area with 2, so we get total area as 8 pi r square. This is the total area. Therefore the energy required to increase the radius from 2 centimeters to 4 centimeters will be equals to E is equals to E2 minus E1. E2 minus E1 means T into 8 pi. We cannot do anything in this. What we can do is in R2 minus R1, R2 square minus R1 square, right? So putting the values of R2 and R1, R2 as 4 and R1 as 2, and solving it, we get the energy as 10.6 into 10 to the power of minus 4 joules, and 10.6 into 10 to the power of minus 4 joules is the option 3. So the correct answer for question number 13 is option 3, that is 10.6 into 10 to the power of minus 4 joule, right? Right. So then next come to question number 20. Now the capacitance between the point A and B of the combination is point A and point B. Point A and point B. 1 is to 2, 1 is to. See here we can see that it's a kind of balanced Wheatstone bridge. Balanced Wheatstone means 1 microfarad upon 2 microfarad is the ratio is 1 is to 2. Here also the ratio is 1 is to 2. Now because the ratio is same, the potential between this point and this point will be same potential. There will be no potential difference. Therefore there will be no charge, or you can say no current flowing in 5 microfarad. Therefore the final circuit between A and B would be like this. right? So this will be your 1 microfarad, this will be 3 microfarad, this will be 2 microfarad, and this is 6 microfarad. So because they are in series, it will be equals to 3 upon 4, and because these are in series, it will be equals to 12 upon 8. 12 upon 8. 12 upon 8 is your 4 threes are and 4 twos are. And because now 3 by 4 and 3 by 2 are in series, so we'll simply add 3 by 4 plus 3 by 2. So this 3 by 2 can be written as 6 by 4. So it becomes as 9 by 4 microfarad, and we have in option 1 itself. So the correct answer for question number 20 is option 1, right? I hope you understood it, because see, we can see that this is balanced Wheatstone bridge, because capacitance of this upon this is equals to capacitance of this side upon this side. P by Q, P upon Q is equals to R upon S, right? This is what is happening here. So there will be no charge flowing through this 5 microfarad. So this 1 and 3 in series will give you 3 by 4 microfarad, and 2 and 6 in series will give you 3 by 2 microfarad. Now this 3 by 4 and 3 by 2 microfarad in parallel sum up to 9 by 4 microfarad. So the correct answer for question number 20 is option 1. That is 9 by 4 microfarad. Coming to question number 21. Question number 21 says that a short bar magnet having a magnetic moment M is equals to 0.80 joule per Tesla is placed in a uniform magnetic field of 0.3 Tesla if a bar magnet is free to rotate in a plane of field, then where U is potential energy associated. So at a stable equilibrium, U is equals to 0.24 joule and T is equals to, torque is equals to 0. So in stable equilibrium, torque will be equals to 0. Here torque is not equals to 0, so this will be wrong. And then stable equilibrium torque is equals to 0, stable equilibrium torque is equals to 0. So out of these three, we have to find that what will be the potential energy. So see, a short bar magnet of magnetic moment is this much is placed in a uniform magnetic field of this much. Okay, so torque for a magnet is given as tau is equals to m into b into sine theta. M b sine theta. So from here, if we calculate the torque, no, here we are not supposed to calculate torque. Torque will be 0. What we are supposed to calculate is the potential energy, and that is equals to minus mg cos theta. Minus u is equals to minus, we can see here, u is equals to minus mb cos theta. We have the value of m, we have the value of b, and theta will be taken as 0. Putting the values, we get u is equals to minus 0.24 joule, minus 0.24 joule, and why the torque will be 0? Because it's in a stable equilibrium, so it will be not be experiencing any torque. Therefore, the correct answer for question number 21 is option 3, that is at stable equilibrium, energy is minus 0.24 joule and the torque is equals to 0. Coming to question number 22, a body of mass m is attached to a lower end of a spring whose upper end is fixed. Now the spring is, do we have the diagram for it? Question number 22, no, we do not have. Now the spring, when the mass m is slightly pulled down and released, it oscillates at a time period of 3 seconds. Time period of 3 seconds. Alright. So the frequency equals to 1 upon 3 hertz. Now when the mass m is increased by 1 kg, then the time period of oscillation becomes 5 seconds. The value of m in kgs is, so time period is given as 2 pi under root m upon k, which is as 3 seconds. So it is equals to 3 is equals to 2 pi under root m upon k. Now the time period of the system is on the increasing of mass by m. So in place of m, we'll write m plus 1. So it becomes, and the time period becomes 5 seconds. So 5 is equals to 2 pi under root m plus 1 upon k, right? Now from here, if we solve both the equations, we get m is equals to 9 upon 16 kilograms. So 9 upon 16 kilograms is the correct answer. That is option number 4 is the correct answer for question number 22. Question number 23. A frame CDEF is placed in a region where the magnetic field B is present. A rod of a length 1 meter moves in with a constant velocity 20 meter per second, and then the magnetic field in is 1 Tesla. The power sent in the process is, where R is equals to 0.2 ohm and all other wires are and the rods are of 0 resistance, right? So here it is kind of, you can say this is the case of a motional EMF, and the motional EMF E is given as BLV. Now once we have B with us, we have L with us, and we have V with us, so we can actually easily calculate your EMF induced. Now once we have EMF induced and we have the resistance, using EMF induced and resistance we can easily calculate the current induced. See, you can see here we have R as 2 ohms, B is given as 1 Tesla, V is given as 20 meter per second, and L is given as 1 meter. So using this BLV we can easily calculate the EMF induced, and once the EMF induced is coming, we are getting it as 20 volts. We divided by R will get the current, and once we have the current, then V into I will give you the power. So V into I is giving you the power, and it's coming as 2 kilowatt. So the correct answer for question number 23 is 2 kilowatt, which is option 2, right? Now coming to question number 24. Question number 24 so says that the three charges Q each are kept at the corners of equilateral triangle, and another charge Q is kept at the center of as shown. The ratio of Q and Q so that it is in equilibrium. Okay, so for understanding this, you may understand this figure. Here is the charge, right? Here is the charge. Now the first force on this would be this one, because of the charge at A. Second force will be your this one, because of the charge kept at B. And the resultant of these two will be equals to 2A cos theta by 2, that is 2F cos 30, because this whole angle will be of 60, so 60 by 2 is 30, right? So we have the resultant of it. Now force between the charge A and B will be equals to K Q square upon A square. Then the force exerted by the charge Q will be equals to FKQ upon A root 3, since this is equals to A root 3. See, we are not having space to draw it. They are saying the charge are kept at the corner of the equilibrium triangle, and this so this is in equilibrium. See, this is in equilibrium means net force on this will be 0. That is, on net force on Q will be 0. So net force on Q will be one force will be because of this Q, another will be because of this Q, and another will be because of this Q, right? So, and the distance between this center point and this is equals to root 3 times of A, because it is the centroid, right? And the distance is this. So force on Q because of other three charges Q will be equals to individual values is KQQ into A by root 2 whole square, right? So because the net force here we have same magnitude, here also we have the same magnitude, and this angle is equals to 120 degrees. So this is nothing but Q upon A by root 3 whole square. This is the magnitude of the force, one force, and both are having the same magnitude and they are separated by an angle theta. So their resultant will be equals to 2A. A is this 2A cos theta by 2. That is what is shown in the figure, this part, right? So now because we have this value, that is k q upon a by root 3 whole square, and this is equals to k q square upon a square cos theta. Solving this equation, we can simply get the value of q upon q as 1 upon root 3, right? So we are because this is an equilibrium, therefore net force equals to 0. So we are equating all the forces here and balancing it, and then solving, we get q upon capital Q is equals to 1 upon root 3, right? Now coming to question number 25. So yes, this question I guess is clear to everyone. To understand it in a more simpler manner, you can understand it like this, that see, this is small q, the diagram is symmetric, so this and these are the two forces because of the base charges, and this is the force because of the charge upside, right? Now this has a magnitude f and this has a magnitude f, so their resultant will be equals to how much? 2a 2f cos theta by 2, and theta here is 120, so here becomes 60. So cos 120 by 2 is cos 60 and cos 60 is 1 by 2, so we get 2f into 1 by 2, so it becomes f. So this is equals to f and this is equals to f. This and this have both different expressions, that is what we have equated here. This is the resultant and this is the force because of third. Equating this, we can easily get the ratio of q by q. Now coming to question number 3. So the correct answer for question number 25 was your, so question number 24 is option 3, that is 1 by root 3. Now coming to question number 25. Question number 25 says that a wire is connected to a battery and the drift velocity of the electron in the conductor is v naught. Now, if the wire is stretched to quadruple its length and connected to the same battery, the new drift velocity is, see, I is equals to NEAVD, right? Now, if we are increasing the length by 4 times, the resistance will increase by 16 times. If the resistance increases by 16 times, current will reduce 16 times, and because from here we can say that I is proportional to Vd, if current is decreasing 16 times, then Vd will also decrease by 16 times, right? So let's see, wait a minute, question number 25. See, drift velocity is, okay, we are using the formula drift velocity Vd is equals to EV tau upon M into I. When the same battery is there, means V is constant. Now because V is constant, we can say that drift velocity is inversely proportional to the length of the conductor, right? Drift velocity is inversely proportional to the length of the conductor. So using that relation, we get your new drift velocity as reduced by 4 times. So the correct answer will be option 1. Question number 25. Okay, right? So here we are not using I is equals to NEAVD. We are using the formula is VD, that is drift velocity, is equals to E, that is charge on the electron. Then V is the potential applied across the conductor. Tau is the relaxation time upon M into L, mass of the charge, and L is the length of the conductor, right? Using this formula, we see that drift velocity is inversely proportional to length. Now, if length is increased 4 times, drift velocity will reduce 4 times. So, we get correct answer as 1. Option 1, that is V naught by 4, because drift velocity is V naught here, right? So I took the wrong approach there. Okay, but the thing was because here the battery is connected, so we cannot use that I is equals to NEAVD because the battery is connected, so this current will not remain constant. This current will change with, as per the resistance, right? So we cannot use I is equals to NEAVD. We will have to use this formula. Question number 26. Question number 26 says that in a single slit diffraction experiment, the first minima of red light means lambda 660 nanometers, coincide with the first maximum of another wavelength lambda 2, then the value of lambda 2 is. Now see, for a single slit diffraction pattern, we have this formula, that is d sine theta is equals to n lambda. So for the first lambda as lambda 1, we have d sine theta 1 is equals to 1 lambda 1 because it's the first minima, right? So sine theta 1 is equals to lambda 1 upon d. For the first maxima, we get the first maxima approximately lies between the first and the second minima. For the wavelength L2, its position will be equals to d sine theta upon 3 by 2 lambda d. For here we have, for the maxima, we have used the formula d sine theta is equals to n plus 1 upon 2 lambda, right? So that is by 3 by 2 lambda 2. From here we get your sine theta 2 is equals to 3 lambda 2 by 2d. Now because they are coinciding, therefore theta 1 will be equals to, theta 2, or we can say sine theta 1 is equals to sine theta 2. So sine theta 1 is lambda 1 upon d, and sine theta 2 is 3 lambda 2 upon 2d. Equating this, we'll get lambda 2 is equals to 2 by 3 times of lambda 1, and because lambda 1 is equals to 660, therefore we get lambda 2 is equals to 440. So the correct answer for question number 26 is option 1. Coming to question number 27. For an AC circuit containing an inductor only, as shown, the graph of inductive reactance XL versus frequency of an AC source is. This is the graph, this is the graph, and this is the graph, and this is the graph. Now see, XL is equals to omega L. So XL is equals to 2 pi F into L. For a given inductor, we find that XL is directly proportional to F. So this graph is not of direct proportion. This is also of not direct proportion. This is a constant graph, and this is of direct proportion. So the correct answer for question number 27 becomes answer of graph number 4, that is option 4. So the correct answer for question number 27 is option 4. Now coming to question number 28. In the network shown in the figure, each of the resistance is of 2 ohm. The resistance between point A and B is. So this particular arrangement can be rearranged as shown in the figure C. If you take this and bring this side, it will become like this, which is a type of Wheatstone bridge. Now when we see that this is a Wheatstone bridge, what we see, it is a balanced Wheatstone bridge. It means there will be no current flowing through this resistor. So now these two resistors are in series, and these two resistors are in series, and these two branches are in parallel. So 2 plus 2 is 4, 2 plus 2 is 4, and 4 upon 4 is 2. So the net equivalent resistance will be equals to 2 ohms, which is option 4. Question number 28, the correct answer is option 4. Coming to question number 29. Question number 29 says that a wire frame of given shape carrying current of 10 ampere is placed in uniform magnetic field of 100 Tesla directed into the plane of the paper as shown in the figure. The net force acting in the frame is. Okay. So this is the frame they have given. So let's see. See, F net is equals to BIL, that is magnetic field strength into I into L. So total length is your this 4 plus 3 plus 5 plus 2, and this 3 and 5 will be equivalent to this 4. This 4. So total length will be 4 plus 2, which is equals to 10 centimeter, which is equals to 0.1 meter. So putting the value of B, I and L in the formula, F is equals to IBL. We have formula na, F is equals to IBL sine theta. So sine theta here is of 90 degrees. So B is 100, I is your 10 ampere and your length is 0.1 meter. Putting this, we get force is equals to 100 Newton. Now by Fleming's left hand rule, this is the magnetic field, index finger, middle finger is your current and thumb will indicate the force. With the help of this, we can see the direction by the left hand rule, the force upward, that is plus y direction. The force will be in the plus y direction, and therefore the correct answer for question number 29 will be equals to 10 J Newton. 10 J Newton, right? Simply this is the current direction and magnetic field is inside. So the force will be upward, right? So the correct answer is option 1. That is 10 J Joule. Coming to question number 30. Question number 30 says two 220 volt 100 watt bulbs are connected first in series and then in parallel. Each time the combination is connected to a 220 volt AC supply, the power drawn by the combination in each case respectively will be power drawn in each case. Now, when they are connected in series, see, when they are connected in series, this is R1 and this is R2. So, power for R1 will be equals to R1 will be equals to V square upon P1, and that is 484 ohms, and R2 is equals to this. This is from their power rating. This is V and this is P, right? So using this P and V, we are calculating the resistance of both the bulbs, that is R1 and R2, right? So now when they are connected in series, the current through the circuit I will be equals to V upon R. R is equals to 484 into 2, that is the total resistance, and it comes as 5 by 22 amperes, right? And then the power will be equals to P is equals to I square into R. So again, your I square into R, it gives as power as 50 watts. Now when they are connected in parallel, each resistance is of 484. So in parallel it will become 242. See, 242, right? Now the power dissipated in each resistor will be equals to, we know that power is equals to V square upon R, and the voltage for each resistance will be same because they are connected in parallel. So the power dissipated in each resistor will be also same. So here we get as 200 watt in one resistor, right? 200 watt in one resistor. So in series it is 50 watt and in parallel it is 200 watt. So 50 and 200 watt is in option 4. So we can see in series the power dissipated is 50 watt and in parallel it is 200 watt. So the correct answer for question number 30 is option 4. Coming to question number 31, 5% of the power of a 100 watt bulb is converted into visible radiation. Average intensity of visible radiation at a distance of 10 meter from the bulb is. Intensity is given as power per unit area, right? Now we have to calculate intensity. The power is 5%. 5% of a 100 watt bulb means 5 watt, right? 5 watt. Okay. So 5 watt upon 4 pi r square, because they are giving us a distance of 100 meter. So the radius of the visibility will be equals to, sorry, 10 meter. So it will be 10 meter and it will be a spherical area, means it will be spread in 360 degrees, na? So we'll take area as 4 pi, or we will take area as 4 pi r square. This is the surface area, 4 pi r square. So we have power as 5 and area as 4 pi r square. So 4 pi and r is 10, so 10 square is 100. Solving this, we get the intensity. So the correct answer for question number 31 becomes option 2. Now, in question number 32, it says a graph plotted between the pressure and the temperature of an ideal gas at two different volume is shown, V1 and V2. Okay. Now, which of the following conclusions can be drawn based on the above graph? Pressure and temperature. Hmm. Wait a minute. Right. Now we have the ideal gas equation is equals to PV is equals to nRT. Now P upon T is equals to N R upon V, right? So we have the graph between P and T. So for a graph between P and T, the slope will be equals to your N into R, and the slope of PT graph is inversely proportional to V. Means more is the slope, less will be the volume. So V1 is more than V2 because slope of V1 is less and V2 is more. So we get that V1 is greater than V2, right? Here we have the inverse relation. Na? When we are calculating P upon T, we are basically calculating what slope, and the slope is proportional to NR upon V. Means NR is a constant, so we can say 1 upon V. The slope is inversely proportional to volume. More is the slope, lesser is the volume. So V2 has a more slope, so V2 is less. V1 has a smaller slope, so V1 is more. So V1 will be greater than V2. So the correct answer is option number 1. Question number 33 says a ray of light is incident on a thin prism with an apex angle of 4 degrees. Now, if the refractive index of the material of the prism is 1.5, then the angle of deviation of the light ray will be. So, it is directly formula based question because for a thin lens, the angle of deviation del is equals to your A into mu minus 1. Right. So, A is 4 and mu minus 1 is 1.5 minus 1 will give you 2. So, angle of deviation is 2 degrees. Angle of deviation is 2 degrees. So, it is 2. Option 2 is the correct answer. So, option 2 is the correct answer for question number 33. Coming to question number 34. In a new system of unit, E is energy, D is density, and power is P are taken as fundamental units, then the dimensional formula for the universal gravitational constant is. Okay, so see, this you will have to look into the solution. This is a large solution. You cannot write everything here. Now, according to the universal law, we have F is equals to G m1 m2 upon r square, right? Now, from here, you can say the dimension of G is equals to m inverse L cube T square. Now see, we say that the dimension of G, let the dimension of G in terms of E, D, and P will be equals to E raised to the power of A, D raised to the power of B, and P raised to the power of C, right? So, and it's the same way we find the relation between some physical quantities. We form the formula, right? Now from here we can say that we can equate the dimension of both the quantities. This is in the terms of MLT and this is in the terms of ED and P. Now m raised to the power of minus 1, L raised to the power of 3, T raised to the power of minus 2 is equals to E raised to the power of A, D raised to the power of B, and P raised to the power of C. So the dimension formula for the energy is this, that is for density is this, and that for the power is this. We put these dimensions here. We will put these dimensions here, and then we will compare the powers, and comparing the powers we will calculate the value of A and B and C, and finally calculating it we get A as 2, A as minus 2, B as minus 1, and C as 2. So finally we get E raised to the power of minus 2, B raised to the power of minus 1, D raised to the power of minus 1, and P raised to the power of 2. So E raised to the power of minus 2, D raised to the power of minus 1, and P raised to the power of 2. So the correct answer is option number 2 for question number 34. For question number 34 is option 2, right? So what we have done is we have equated the dimensional formula for gravitational constant in terms of M, L, and T with a dimension formula e raised to the power of a, d raised to the power of b, and p raised to the power of c. And then writing the dimension formula for e, d, and p, and then comparing the powers and calculating the value of a, b, and c, we get our answer as option 2 for question number 34, that is e raised to the power of minus 2, d raised to the power of minus 1, p square. Now coming to question number 35, when two bodies are separated by a distance, the gravitational force between them is F. If the distance is decreased 50%, then the gravitational force becomes. So if the distance is decreased by 50%, if the distance is increased by 50%, the distance becomes 3d by 2, and because it is in a square, it becomes 9d upon 4. So 4 upon 9, so 4 becomes 4 upon 9 times. So 4 becomes 4 upon 9 times. So the correct answer for question number 35 is option 2, right? Because we have the formula F is equals to G m1 m2 upon r square, or you can say d square. So F is proportional to inversely proportional to d square. Now d changes from d it is changing to 3 by 2d. So squaring will give you, it is changing to 9 by 4d, right? Now because it is denominator, force will get 4 by 9 times, right? Now coming to question number 36. In Young's double slit experiment, the intensity of light at a point on a screen where the path difference of lambda is I naught. Then the intensity of light at a point where the path difference becomes lambda by 3 is. Now see, again this is look into the solution because the solution is long, we cannot write everything. See, path difference lambda is equals to, path difference is delta x is equals to lambda. Now therefore the phase difference phi is equals to 2 pi by lambda into delta x, and instead of delta x we will write lambda. So this lambda and lambda cancels out. See, delta, that is delta x. Delta x is path difference is given as lambda in the question. We have to use lambda in the question. So it is 2 pi by lambda into lambda. So this lambda and this lambda goes off. What we are left is the phase difference as 2 pi. Now because the phase difference is 2 pi, the resultant intensity I is given as I1 plus I2 into 2 under root of I1 I2 cos phi. Putting phi as 2 pi and cos 2 pi is 1. So we write it as I1 I2 is equals to I1 I2 I1 plus I2 plus 2 under root of I1 I2. Right. Now for I1 is equals to I2 is equals to I, we get resultant intensity as I naught upon, we get resultant intensity as I naught upon 4. Right. Now if the path difference delta x is equals to lambda by 3, then we again put here 2 pi by lambda into lambda by 3. So we get phase difference phi as 2 pi by 3. Now putting phase difference as 2 pi by 3, we again get our intensity as resultant intensity I is equals to I naught by 4 units. Right. So on the basis of this calculation, we get our correct answer for question 36 as option 2, that is I naught upon 4. Right. They are asking you the intensity of light at a point where the path reference is lambda by 3. First they have given you the reference of lambda, and then they are asking for lambda by 3. So first we have calculated for lambda, it is giving us I naught by 4. Then we calculated for lambda by 3, it is again giving you the intensity as I naught by 4. Why? Because in both the cases the phase difference is so that it has a value, same value, right? Now coming to question number 37. A block of mass 2 kg is placed on the top of a block of mass 4 kg as shown in the figure. The coefficient of the friction between the block is 0.2 while the ground is smooth. The acceleration 2 kg blocks with respect to the ground is. Now see, uh, assuming that they are moving in the common acceleration, so common acceleration, the net force applied is what? 24 newtons and the total weight is 6. So 24 upon 6 will give you 4 meter per second square. This is the common acceleration they are moving. Now the friction required to provide 4 meter per second square acceleration of 2 kg block is, so 2 into 4 is equals to 8 Newton. We have the mass, we have the acceleration, so force required is 8 Newton. Now limiting value of the friction is mu into 2 into g, so limiting friction force is coming as 4 Newton, right? Limiting friction force is coming as 4 Newton. So what we can see here is that is the force experienced by the 2 kg block is greater than the limiting friction force. Therefore, the slipping would occur. Because the applied force or the experienced force is exceeding the limiting friction force. So therefore, definitely there will be a relative motion between the two surfaces, and hence the block will be slipping over. So friction acting on the 2 kg block will be 4 Newton, and hence the acceleration will be equals to 2 meter per second square. So the correct answer for question number 37 will be equals to 2 meter per second square, which is your option 4, right? So coming to question number 38. Question number 38 says that a vernier caliper is found that the 4 divisions of the main scale coincide with the 5 divisions of the vernier scale, uh, the least count on the vernier scale. So they are asking the least count. So 5 vernier scale divisions equals to 4 main scale divisions. So 1 vernier scale division is equals to 4 by 5 main scale division. Unitary method. Then the least count is equals to main scale division minus vernier scale division. So 1 main scale division minus 4 by 5 times of mean scale division. So we'll give you 1 by 5 mean scale division, that is 1 by 5 units, right? So question number 38 has its correct answer as option 2, that is 1 by 5 units. Coming to question number 39. Water is flowing with a velocity of 4 meter per second in a cylinder of diameter 8 centimeter. It is connected to a pipe with the end tip of diameter 2 centimeter. Calculating the velocity of the water at the free end is. Principle of continuity, A1 V1 is equals to A2 V2, right? Principle of equation of continuity, A1 V1 is equals to A2 V2. Diameter has been given to us, so from there we can calculate A1 and A2. Velocity V1 has been given to us, we have to calculate velocity V2. Putting the values in the formula will simply give us the answer as 64 meter per second, which is option 4 in the question, right? Now coming to question number 40. A current of 30 ampere is flowing in a conductor as shown in the figure, from here, then like this, and then like this, okay, and the radius is 3 centimeters. The magnetic induction at point O will be, so magnetic induction at point O will be, because of a ring circular coil, the center it is how much? Mu I upon 2r. Here we can say that this is, because this is given as pi by 2, it means this is 90 degree, and because this is 90 degree, this is one of the quarter removed. One of the quarter removed, we have 3 quarters left. So if the complete ring has its magnetic induction as mu naught I upon 2r, then the quarter 3 by 4 ring will be have 3 by 4 times of mu naught I upon 2r, right? Now we have the values of I and R. Putting the values, we'll get B is equals to 1.5 pi into 10 to the power of minus 4 Tesla, which is your option, 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 option 2. Yeah, option 2. Option 2. Now coming to question number 41. 41. Each of the two large conducting parallel plates has one-sided surface area A. If one of the plate is given as charge Q, whereas the other is neutral, then the electric field at the point in between the plates is given by. See, when a positively charged plate is brought close to another similar identical plate, then because of the induction, what will happen? There will be some charges over here. Now, as we know, the electric field is equals to Q upon total area into epsilon naught. So it becomes total area is equal to sum of the area of the both, that is 2A. right? So the electric field intensity becomes E is equals to Q upon 2A epsilon naught, right? So E will be equals to Q upon 2 into A upon epsilon naught. Phi, or you may understand it in a different way also. You can say that phi uh, E dot ds. Okay, let it be, and this is enough. That is E is equals to Q upon 2A epsilon naught. So the correct answer for question number 41 is your option 2, that is Q upon 2A epsilon naught, right? See, we know we know that this is E is equals to Q upon A epsilon naught, and this A is the total area. So E, so this A is 1 and 2, so 2A. Now this 2A, so we write it as 2A, and this formula becomes like this: E is equals to Q upon 2A epsilon naught, which is option 2. Now coming to question number 42, two wires of same metal have same length. Two wires of same metal have same length, but their cross-sectional area are in the ratio 3:1. They are joined in a series. The resistance of the thicker wire is 10 ohm. The total resistance of the combination will be. So if the thicker wire is of 10 ohm, thinner wire will be of 30 ohms, right? Because area of cross section is 1/3. Because area of cross section is 1/3, so the resistance will be 3 times, right? So see, if R1 is 10 ohm, the thinner wire will have its resistance as 30 ohm. Because they are connected in series, 10 and 30 connected in series will give you equal it as 40 ohm. The correct answer is 40 ohm, that is option 1 for question number 42. Coming to question number 43, a ball is projected at an angle of theta which is greater than 45 degrees from horizontal at a speed of speed u. If after time t the value of the vertical component of the velocity becomes equal to the value of the horizontal component of the velocity, then so vertical component of velocity is becoming equal to the horizontal velocity. So vertical component Vy is equals to Uy minus dt, that is Vy is equals to u sine theta minus dt. Okay. Now u cos theta is the horizontal component, and u cos theta always remains the same. So u cos theta is equals to u sine theta minus gt. Rearranging it, we get t is equals to u upon g into sine theta minus cos theta, which is nothing but option 2 in our question. That is correct answer for question number 343 is option 2. It was an easy question. Question number 44. The convex lens A of focal length 20 centimeters and concave lens B of focal length 5 centimeter is kept along the same axis with a distance of D between them. If the parallel beam of light falls on A, leaves B as a parallel beam, then the distance between them D is C. So to understand it, if you understand it like this, from the diagram, parallel beam is entering into a convex lens and it is exiting a concave lens as a parallel beam, right? As a parallel beam, then the distance between the two lenses is. So if suppose there was a no concave lens here, then this light, which is a parallel beam, when passes through the convex lens, will converge at its focus, right? Now this is the focus of convex lens. Now, any light ray which is traveling outside a concave lens, which is and they are parallel to each other, it means they might be coming from the focus. So, this point is also the focus of concave lens, right? This point is also the focus of concave lens. So, this distance is the focal length of concave lens. This distance is the focal length of convex lens. We need this distance. So if we subtract focal length of concave lens from the focal length of convex lens, we can easily calculate the D. So focal length of convex lens, the focal length of convex is 20 and that of concave is 5. So our answer should be option 2. So the correct answer for question number 44 is option 2. Right. Now coming to question number 45. Question number 45 says that a disc of mass 3 kg rolled down an inclined plane of a height of 5 meter. The translational kinetic energy of the disc on reaching the bottom of the inclined plane. So see, mass is this much. When it is rolling down, disc is it rolls down, right? When it is rolling down, it will have two kind of kinetic energies. There is rotational kinetic energy and translatory kinetic energy, and that would sum up to the potential energy. Potential energy equals to mgh. Mass is 3, g is 10, and h is 5. So we get as 150 joules. Now this is the potential energy at the top. Now this potential energy will convert into kinetic energy. So by the energy conversion, the potential energy at A plus kinetic energy at A is equals to potential energy B plus kinetic energy at B. Now kinetic energy at A is 0 because it is at rest. Potential energy at B is 0 because now it loses its height. So potential energy at A will be equals to kinetic energy at B. So potential energy at A is 150, but the kinetic energy at B will be your translatory kinetic energy plus rotational kinetic energy. So energy, kinetic energy at B will be equals to half mv square plus half I omega square. So half mv square plus half I omega square. I is equals to half mr square, right? And omega is v square by r, v by r. So v by r whole square. Putting all the values and solving it, we get kinetic energy at B is equals to 3 by 4 v square, right? And kinetic energy at B will be equals to potential energy at A, which is equals to 150 joules. So 150 joule will be equals to 3 by 4 of mv square. Solving this, we get mv square is equals to 200, and therefore half mv square is equals to 100 joules. So the correct answer for question number 45 is 100 joule, which is option 2. Coming to question number 46, the fundamental frequency of a closed organ pipe is equal to the first tone frequency of an open organ pipe. If the length of the organ pipe is 60 centimeter, what is the length of the closed organ pipe? Now, for a closed organ pipe, fundamental frequency is equals to V by mu by 4L. Whereas for an open organ pipe, fundamental frequency is equals to V by L. But according to the question, both are equal. Here both are equal. So equating this, what we get is the length of the closed organ pipe should be 1 by 4 times the length of the open organ pipe. Now because open organ pipe is of length 60 centimeters, therefore the length of the closed organ pipe will be equals to 15 centimeter. Right? It's again, the formula is all about remembering the formula for a closed organ pipe frequency and for an open organ pipe frequency. Coming to question number 47, question number 47 says that a diamagnetism is independent of temperature. Reason is induced dipole moment is a simple is a sample is diamagnetic, always opposite to the magnetizing power, no matter what internal motion of the atom is. So this reason is the correct explanation for assertion. So we can say the correct answer is option 1, that is if both assertion and reason are true and the reason is the correct explanation. Let's see what they have written. The diamagnetic is almost independent of the temperature. Yes, this we know. The diamagnetic property is independent of temperature, and this is because the diamagnetic atom lacks its intrinsic magnetic dipole moment. Now when the dipole uh, when a diamagnetic sample is placed in a magnetic field, its magnetic moment is always in the opposite direction of the field. It is not affected by the thermal motion of the dipole. Therefore, both the assertion and reason are correct. Diamagnetism is independent of temperature. You should know this. Then coming to question number 48. Question number 48 says that in the figure, potential of plus 1200 volt is given at point A and B at point A and point B is Earth. What is the potential at point P? What is the potential at point P? Okay. So Alright. So this 4 microfarad and 2 microfarad are in series. So they can be added and equivalent will be 6 microfarad. Now this 6 microfarad and this 3 microfarad are in series. So the potential will be distributed among them and their equivalent will be equals to 2 microfarad. Now this 2 microfarad is experiencing a potential difference of 1200 volts across its plates, right? So the charges in both the capacitor will be same because they are in series, that is as 3 microfarad and 6 microfarad are connected in the series, charge in both will be same and charge is given as C1 V C into V. So for the first capacitor it will be C1 into V1 and the second capacitor it will be C2 into V2, right? Now we have the value of C, we have the value of C1 and we have the value of C2. Let V2 is equals to X, then V1 will be equals to 1200 minus X, and now then solving it we get Vp, that is one of the potential difference is 400. So the correct answer for question number 48 is option 3, that is 400 volt. Coming to question number 49, two identical glasses of refractive index 1.5 equi-convex lens of focal length f each are kept in a contact. The space between the two lenses is filled with water. The focal length of the combination is. Do you have the diagram? No. See, they are saying that the two identical glass equi-convex lens of focal length f each are kept in a contact. The space between the two lenses is filled with water. So this is a convex lens. This is another convex lens. They are kept in contact, and the rest is filled with water, right? And they are asking the focal length of the combination. So focal length of the combination is, first we should know that this is a lens maker's formula. Then according to see, for a convex lens R is positive, R1 is positive. Yes, R1 is positive. Why? Because this, for this R1 is this direction, in the direction of incident ray, and if this is the second surface, this is R2 which is in the opposite direction. So R1 is positive and R2 is negative. The sign convention, right? Now since both the lenses are identical, we can denote the radius of the curvature as capital R. Now for each lens, 1 by f is equals to 3 by 2 minus 1 into 1 by r. Doing the calculation, we get f is equals to r. Whatever is the focus of the lens will be equals to the radius of curvature. Now the water in between of the lenses can act as a concave lens of the refractive index. Now it is a concave lens. Why they are saying it a convex lens? Concave lens, because if you see, this is a convex lens. Again, this is a convex lens. So this portion which I am shading is filled with water. So this portion will appear as a concave lens. You can see, this is a concave lens, right? And this has a refractive index of 1.5. So if it has a refractive index of 1.5, we can easily calculate the focal length of this appearing concave lens using the lens maker's formula. So that is what we are doing here, is using the lens maker's formula to calculate the focal length. Now, although we are bringing only two convex lenses in contact, but this arrangement would appear as if there are three lenses in contact. One is convex, then is a concave, and then is a convex. So we have three lenses in contact. It would appear as if there are three lenses in contact. So we will have the equivalent focal length as f1, 1 upon f1 plus 1 upon f2 plus 1 upon f3, where f1 and f3 will be the focal length of the two convex lenses and f2 will be the focal length of the concave lens formed with the help of water. And then putting the values, we get f equivalent is equals to 3f by 4, which is option 4 in the question. So correct answer for question number 49 is option 4, right? Again for question number 49, there are two convex lenses. So and the gap between them is filled with the water. So whatever space is occupied by the water, it appears as a concave lens. So in this question, we can take a combination of three lenses. two convex lengths and one concave length. So to calculate the equivalent focal length, we will add three focal lengths over here. Now coming to the last question, the escape velocity from the Earth's surface is v. The escape velocity from the surface of another planet having radius 4 times that of the Earth and same mass. So escape velocity, we have the formula escape velocity is equals to under g and 2g m by r, and which can be also written as 8g rho pi r square upon 3, and from here we can say that escape velocity is directly proportional to r. Now if radius is the planet 4 times, then the escape velocity will also be 4 times. So the correct answer for question number 50 is option 1, that is 4 times, right? So I hope you all understood all the questions. If I would have missed anything or you have not understood anything, please put it in the comment box so that that could be explained or the mistakes could be rectified or would be clarified. Okay, so this is all for today regarding your BPT 21 solution, right?